So I hope everybody sees my slides. Thank you for joining today. And the first part will be a little bit more technical, but actually it's more for informational purposes, so you understand what PANGAEA Pi and PANGAEA R is doing in the back end. So for end users which are working in PANGAEA, which are working in Pi or R, it might be better to use one of the prepared libraries, but in general, this also helps you to also work together with other data centers because it shows you what specifically on the technical side is required to be a fair, compliant repository, findable, accessible, and the accessible is in that case very, very important. So it must be accessible by machines. And this is what this talk is about. How you can, if you have identified the DOI of a data set, download its data, get its metadata, and so on from program code. And if you use PANGAEA Pi behind the scenes, it is working exactly like that. The first is about the PANGAEA metadata dissemination. It's just the background of the PANGAEA metadata. You have seen a lot of data sets yesterday, but the display of the metadata you see on the web page is just a few of what's behind our behind the scenes in our system. So the metadata and also the data of a PANGAEA data set is saved in a relational database, which is the RDBMS on the left side. And from there, all the metadata of each data set is serialized to something which we call the PANGAEA internal metadata format. There's a wiki page about that. It was shown to you yesterday regarding the search engine, because what the search engine of PANGAEA indexes is exactly that metadata in the PANGAEA specific format. And that is what you're querying from the web page or when you're viewing a data set and downloading the data. And this metadata in the PANGAEA internal format is then also transformed on request to several other metadata formats which are standardized worldwide. For example, one from the geosciences is ISO 19139, which is going back to the 2005, which is used in general for many, many data portals, like, for example, EMODNet or anything like that, used. The other one is Dublin Core, for example, or Dublin Core is just a basic citation metadata. DIF is an old metadata format. It's no longer supported by PANGAEA, but we still have it in our thing. Then DataSite metadata is what is used to register DOI, and that's also very, very informative for somebody outside because it's standardized across all the repositories using DOIs. So if you want to find data sets, it's often a good idea to simply go to DataSite and search there. And then if you have found something from PANGAEA, go to PANGAEA or another data center. And there are the modern one is schema.org. And this is the metadata format, the most modern one, which is included in all the landing pages you see. I will show that a little bit later, and is used, for example, by Google and all other search engines outside. So Google Dataset Search is using that. And that's the most modern one. It's also the most complete, and interestingly, it's very, very similar to the PANGAEA internal one. So 20 years ago, when we invented the PANGAEA metadata schema, it was already very, very close to the modern standard of schema.org for datasets. So, and this is all needed for a fair compatible repository, and I show you now how those machines here on the right side, like for example Google, are getting the metadata and the data of datasets. And the first thing is, you only have a DOI and you want to get the metadata behind that DOI. But actually, PANGAEA does not have an API for that because there's no API needed, because in the web standards it's already included that you can access metadata and data by some special mechanism. If you only have the DOI, you can request that DOI and say, I don't want to see the HTML page that you see in your browser, but instead I want to get the information in machine readable form. And that's especially important to be a fair compatible repository, because that's one of the requirements, that your repository is able to deliver the metadata for machines, not only for humans, sitting in the browser, opening a DUI. And there are two mechanisms for doing that. The first one is HTTP content negotiation. And that one is simply available, so you can tell, I have that DUI and I want to get the data in that metadata format. For example, in the ISO 19139 metadata format, or I want to download the data. And this can be told to the URL when you fetch it, also with your Python script or R script. I want to have the tab delimited matrix of that DUI. That can be done. It not only works with PANGAEA, it also works with other data centers. Or you can tell it, I want to have the metadata. And the other thing is, if you want to figure out what offers that DUI, what can you do with that DUI, what formats are available, then there's another standard which is called signposting. It comes mostly from the scientific community, which tells you what different representations of your resource, the DUI in that case, are available. And that's all standardized by the W3C, which is a standard, the web standard. They are also doing those protocols like HTTP. They are standardizing how web browsers work internally, and this is also standardized by them. So, for example, if you have the data set, this is all machine readable. So you can read here the citation, everything. But actually, for a machine, this is meaningless because you understand it, because it's visually like something you would understand. But for a machine, it's completely impossible to understand what you're seeing here. So actually, what you need is, for a machine, some entry point to that landing page to figure out the machine readable information. And there are, as said before, those two types here. You want to figure out, how can I download the data? What formats are available? And there are two possibilities. One is so-called link header. So actually, when you send a request, so when your browser sends a request to the web server, it also gets some metadata about the web page. So we're talking about metadata the whole day yesterday, but this case, it's metadata about the web page. And this metadata also contains information how to access or what other representations are available. So we have, for example, the landing page. It tells your browser how to cite it. For example, this is used if you, for example, have that plugin in your browser where you can import citations from web pages of publishers and also from PANGAEA. If you click on the button, it reads that information. It can also get all the information about authors, the resource type, or the metadata formats that are available. So, for example, you can trigger that with curl. So actually, the examples I'm showing here are all using that command line curl, which is available on all Linux platforms and Windows, which is a standard tool to download something from an URL. It's just for demonstration purposes. If you program something, you would do that in Python, of course. So actually, you can take any DUI, and then using that command here with the LE, L means follow links, I means just print the metadata of that DOE here. And then what you get is here, the first is the web server of the DOO Foundation says where the DOI is going to. In our case, it goes to the web server of PANGAEA. So you are redirected here. And then in the second step, our web server is telling you a lot about that DOI on our site. There's also in which format it's available, how large it is, and all that. But there's also an important thing, is that the signposting standard, it's a link header where it says what other formats are available for that DOI. And this is grouped by the type. And actually, you have to look for the correct type. And so if you want to download, is it a tab delimited text? You see here, if I want to get it as tab separated values, here's the URL. So this is machine readable because they are standard. You can do that in Python, interpret that, so you can figure out. You can also get the metadata in PANGAEA's own format, or you can get a citation for it in all cases. Here, also the authors are listed if they have an ORCID. So it's a reference. So this is readable by machines. Actually, if you look and open it in your browser, you can also see that information. If you click on the network settings in your browser, you can also view here for the page you see here. The browser is also getting that information and can do something with it. But the browser is also getting it inside the HTML text, which is not so really useful for machines, but this is, for example, useful for Google to figure out what other resources are available for that dataset. So actually, if you view the source of the Pangea dataset, you will also see a lot of those link headers inside the HTML. But this is harder to pass, so the easier way is to just use that what's directly given as metadata on the wire. So that's actually what informs you about what formats are available. But if you already know what you want to have, like you know the content type, so as seen here before, we wanted to have it as text tab-separated values, you can also directly query the DOI and ask it, I want to download the data as tab-separated values. And that's also possible. So the first one is here we can use the link as said before, just download the link with curl. But this is, we need to know the link before, and this may vary between data centers. It's for Pangea, it's always format equal text file at the end, but other data centers can have it differently. So actually, the more correct way to do that, and also what Pangea Pi is using, you are sending together with the DOI of Pangea, you are asking it, I want to have that DOI not in the HTML, but I want to have it as text tab-separated values. And if you send that, then it downloads the dataset as a tab-delimited text file. Cool, isn't it? So actually, there's also another idea. If you don't know the exact format that Pangea returns, you can also send simply application X download as a fake content type at Pangea, which if it's a zip file, it will download it as a zip file. You have seen the collections yesterday. But actually, if you're using Pangea Pi, it will always ask for text tab separated values, because if it's a collection data set, our server responds, no, there is no text tab separated values for that collection data set. And then Pangea Pi is showing you this is a collection data set, you cannot download data of it, for example. So actually, in that case, Pangea Pi always executes something like that when you're requesting the data from the Pangea database. So actually, as an alternative, we can of course also get the ISO 19139 metadata from the browser. This might be interesting for some data product. I just show it for completeness. So you can query anything that's available using the signposting and process it in your software. Actually, this happens also in the fair checker. So the fair checkers are all checking those URLs that they are working on your repository to figure out if your repository is technically a fair repository on that side. So the last one I want to talk about, which is also important for Pangea Pi, is the problem with protected data sets. So for example, many of the data sets are currently on the moratorium, or it's your own data sets which you have not yet published and you want to work with them. So the question is, how can you pass the username and password to the web service during that content negotiation? So you can download the password protected datasets, because if you do that, you will just get an error message on Pangea Pi which says this download is not available for you. You cannot download it because you have not logged in when you're using Pangea Pi. So actually, to explain how it works is you cannot send the username and password with your script. That's impossible also for security purposes. So there's another mechanism, and that's called bearer tokens. And that's what I quickly show you by an example with cookie monster. And the cookie monster is just, it wants to get cookies from that factory there, and to get cookies, it needs to authorize somehow by the factory. So it first tries to get the kekse from the factory, but the factory in the first thing tells you, sorry, 401 is the HTTP error code for this is not accessible for you. You need to identify yourself. That's exactly what happens when you access it with Pangea Pi. For example, it cannot get the data because you're not allowed to get it. So in that case, the cookie monster does not get the cookie. So now the thing is, the login the Pangea system needs to be done by a separate instance. In that case, there's something like an authorization agency, which is the red one here on the bottom, which is there for authenticating the user, so it checks the username and password. So actually, what the cookie is now giving to that extra service is, I have here the username and password, and I want to log in. And then the service returns back, okay, you are fine. You are allowed to enter with that username and password, and I give you something which is a token. And the token is something like a coin or whatever that you have if you go to the Volksfest Jahrmarkt, you know, and you give it to the person who is allowing you to enter that attraction or something like that. So in that case, our cookie monster is sending the token together with the request for the cookie together as an authorization header, and then it's allowed to get that information. So for Pangea, it's the same. So you have to first log in to Pangea, and once you have logged in, so this is that box on the bottom right. So once you have logged in, you can go to the profile page in Pangea, and there you find on the bottom of the page something which is called your temporary login token. And this is actually the key for downloading datasets. Your browser is using that internally, automatically when you're downloading data. But this is exactly what you need to tell your application, that it sends it together with the request to the DUI, is that token which identifies you as with your name, so the service on our side knows that it can deliver the data to you. The good thing and the cool thing with that is, for example, if you hack that token maybe in your Python script and it's sitting there, if you would put in the username and password there, you would have a problem if you give the script to somebody else. So if you just put the token here and give the script accidentally to somebody else, this other person could of course download your data, but it doesn't get your username and password. And the cool thing is you can simply log out, and then the user cannot do anything anymore with the token. So you can invalidate the token. And because of that, for security reasons, you have to put in the token into your script, because there's no risk anymore that your username or password is getting lost or sent to somebody else when you share it, for example, with your colleagues and that. So actually, you can send that header here, and we see now in the next talks how to enter that into Pangea Pi, that token. You now know you have to log in first, and after login, you have to click on that button here on the top here to go to your profile homepage, where you can also change your username, your email address, and there you can get the token. You can copy paste it to your script afterwards. So that's needed possibly not today, because we're only working with open access data sets in our schedule, in our lection. But you need to keep that in mind. I think Katrin will show that to you, how to enter that token to you. So the last one is about the Pangea search, and I have to tell you at the moment, there's no official or documented API to the Pangea search. There will come a search REST API in the future, but at the moment, Pangea Pi and Pangea R have an internal implementation for searching datasets in Pangea, which is available there. It has some limitations because it's only for the web page and not for machine usable. So it's a little bit limited. So for example, it returns HTML pages and all that, but Pangea Pi is quite good in parsing that. So you have to keep that in mind. Unfortunately, I told that last year already, but we have a lot of to do at the moment. So we still have no public API for the search interface. So that's the only downside. We will inform you if there's one available that's officially usable and documented. So the alternatives are to use the data side search. You can go here. The good thing with that is you also find data sets which are not in Pangea that you might use. So that's one possibility that you can use if you want to have an REST API for searching data. So, and if you have found it, the data access can be done using content negotiation. So that was my last word here on that one, and I hope you enjoyed it. So I think
I definitely did. It's always a pleasure to hear you talking about
I hope it
about
was
these
not too
technical
technical, but
details.
I tried to explain it a little bit with the cookie monster, and I didn't know the word for, how is it called when you go to Volksfest in English?
I don't know. Maybe somebody in the audience
Yeah,
knows.
yeah. It's like the cookie you get when you when you're entering that auto scooter or